Alright, so I think we have a pretty good appreciation of how we have some smaller ions, amino acids, glucose, and even water that can leak through these fenestrations and get into this space right here. So remember, this is just Bowman's space. And they can get into Bowman's space where we can then process them into the rest of the nephron. So this is Bowman's space, and we have these podocytes that hug the arterioles right here by holding on to the endothelial cells, and we also have this basement membrane that prevents giant proteins in our red and white blood cells from leaking through, and we have these tubule cells that help line the other side, and they're epithelial cells. They're in the class of epithelial cells. Excellent. Now the last thing I sort of want to cover is just what's happening here from having an arteriole go into a structure and then give off another arteriole. That's a little weird, right? Because we usually like thinking about arterioles going into capillaries and then giving out a venule. Well, one way I think about this is sort of like a marathon, where there are a lot of people running on the same street from point A to point B, and they're either running in a narrow street or a wide street. So let's make a table to sort of think about this. What would happen if we look at our afferent and our efferent arterioles, and we change the diameter of the vessel? What does that do to the rate of filtration? So I'll just write filtration right here. How does the diameter of our vessels change the rate of filtration? Well, if we increase the diameter of the afferent arteriole, or if we have a very wide path that allows a lot of marathon runners to run into the glomerulus, that means there's going to be a lot of blood here. That includes all the ions and the amino acids and glucose, in addition to our blood cells and giant proteins we talked about. There's going to be a lot of stuff over here. And so if there's a lot of stuff running over these fenestrations, you're going to have a lot of leakage. And so there's going to be a lot of filtration. So more filtration occurs if there are more people or more marathon runners running into this space right here. So more filtration. Now what about if we did that with the efferent arteriole? Let's say we increase the diameter of the efferent arteriole, so there's space for more marathon runners to run away from this very narrow street, or this place where a lot of people can run off the pavement and get into these holes and go elsewhere. Well, if we increase the diameter of our efferent arteriole and allow people to leave, they're not going to be able to stay around here for a long period of time. They're not going to be near these fenestrations. So that means that our filtration rate will decrease, because the blood is moving away from the place that it would be filtered. Now the same thing goes if we decrease the diameter of our afferent arteriole. If we decrease the amount of runners or blood that can come into the glomerulus, that means there's going to be less fluid filtered out, so the lower filtration rate. And this is actually what happens with renal artery stenosis, right? If we have a very narrow or stenosed vessel, that's what stenosis means, it's just narrow, renal artery, that means there's going to be less blood that branches off and goes to our afferent arteriole. So there's going to be less blood that runs across our fenestrations and is filtered away. On the flip side, if we decrease the diameter of our efferent arteriole, that makes it difficult for our runners to leave this fenestrated vessel. And so there's going to be some backup. There's going to be a lot of ions and amino acids and glucose kind of hanging around here near these holes. And so if blood backs up, that means so do these guys. And so then they're going to just be filtered through these holes and collected into Bowman's space. So our filtration rate will increase. It'll increase because there's a lot of backup that allows more time for filtration. Maybe if you're interested in learning about kidney diseases later on, there's a lot of stuff that tweaks this system, that messes around with the afferent arteriole or the efferent arteriole, sort of like what I talked about for renal artery stenosis. And I encourage you to think about what can go wrong with this process and how things can change. That's kind of the best way to learn about it. So that's how our glomerulus works. Let's move on to the next part of our nephron.